I'm analyzing user interactions with products using Sklearn, Spectralcoclustering. It's a method to group both users and products simultaneously. I've set the number of user clusters to 5 and product clusters to 3. After running the algorithm, I want to understand the meaning of the *row _labels _ for users, and *column _labels _ for products, outputs. What can I say about them? This question checks if I understand how Spectralcoclustering works and what its results mean. Spectralcoclustering groups both rows and columns of a dataset. The results, *row _labels _ and *column _labels _ tell me which group each row, user, and column, product, belongs to respectively. This is the overarching topic, exploring a technique to simultaneously cluster users and products. Since I specified 3 product clusters, the *column _labels _ array will contain 3 unique integer values, each indicating a different product group. The length of the *row _labels _ array will match the number of users in my dataset, because each user receives a cluster label. The length of the column _labels _ array matches the number of products because each product also gets assigned to a cluster. Because I chose 5 user clusters, the *row _labels _ array will have 5 unique integer values showing which cluster each user belongs to. This is the overall technique we are using. We're analyzing data to find groups of users and products that behave similarly. It's like sorting a giant box of toys into smaller, themed boxes. Cool, right? I'm checking if the length of the row _labels _ list matches the number of users in my data. Think of it this way. Every user gets assigned to one group, so the number of group assignments equals the number of users. This is similar to the previous point, but now I am looking at products. The column _labels _ list's length should match the number of products. Each product gets assigned to a product group, so they must be the same size. These are the results after running the co-clustering. Row _labels _ tells me which group each user belongs to. Column _labels _ does the same for the products. I'm working with a dataset that shows how users interact with products. Think of it as a big table. Each row represents a user, and each column represents a product. Many cells in this table will be empty because a user hasn't interacted with every product. It's sparse because it's mostly empty, pretty common in real-world data. I want to group users and products into clusters. I'm deciding to have 5 user clusters and 3 product clusters. This is like sorting users into 5 groups based on their buying behavior and products into 3 groups based on their similarities. Let's see what happens. After running the algorithm, I get 2 important pieces of information. *row _labels _ tells me which cluster each user belongs to. *column _labels _ tells me which cluster each product belongs to. Think of them as lists assigning each user and product a numerical group label. Because I specified 5 user clusters, I expect to see 5 unique numbers in the *row _labels _ list, each number representing a different user group. Similarly, I'll find 3 unique numbers in the column _labels _ list, because I chose 3 product clusters. The shape of row _labels _ will match the number of users in my dataset. It's the length of that user cluster list. The shape of column _labels _ will be the same as the number of products in the dataset. It's the length of that product cluster list. I set the number of clusters for users and products. I want 5 user clusters and 3 product clusters. Think of it like sorting users into 5 groups and products into 3 groups based on how they interact. After running the spectral co-clustering algorithm, I get 2 key outputs. *row _labels _ tells me which cluster each user belongs to, and *column _labels _ tells me which cluster each product belongs to. I'm working with a dataset showing how users interact with products. It's a sparse matrix, meaning it mostly contains zeros, reflecting that most users don't interact with most products. Rows represent users, columns represent products, and the values show interaction levels, probably using a rating or count. This is true, since I specified 5 user clusters, n_clusters equals 5, 3. The row labels array will assign each user to one of 5 unique numerical cluster labels, like 0, 1, 2, 3, and 4. These are labels, not actual cluster descriptions. This is also true. I requested 3 product clusters, so each product gets assigned one of 3 unique numerical labels, e.g., 0, 1, 2, in the column labels array. Absolutely true. The shape of row labels will be the same as the number of rows in my user product matrix. This is because each row, each user, gets a cluster label. It's like giving each user a sticker indicating the group they're in. You got it. The shape of column labels matches the number of columns, number of products, in my original data. Every product receives a cluster label. I'm working with a dataset showing how users interact with products. It's a sparse matrix, meaning most of the entries are zero, because not every user interacts with every product. Rows represent users and columns represent products. I'm using the Spectral algorithm, and I've told it to find 5 groups of users and 3 groups of products. That is what 5, 3 means. I'm using a machine learning algorithm from the Sklearn library called Spectral. It's designed to find clusters in both the rows and columns of a dataset simultaneously. After running the algorithm, I get 2 important pieces of information. Row labels tells me which cluster each user belongs to, and column labels tells me which cluster each product belongs to. Because I asked for 5 user clusters, the row labels will contain 5 different numbers. These numbers act as cluster identifiers. For example, it might assign labels like 0, 1, 2, 3, and 4 to represent the different user clusters. Similarly, because I requested 3 product clusters, column labels will have 3 different numbers to represent the different product groups. It might use labels 0, 1, and 2, for instance. The shape of the row labels array will match the number of rows in my original dataset. This is because each row, each user, gets assigned to exactly one cluster. Likewise, the shape of column labels will be the same as the number of columns in my data, as each column, each product, receives a cluster assignment. These 4 points, 2 to 5, are the components that are relevant to understanding the results from running the Spectral algorithm. I'm analyzing data using a technique called Spectral Coclustering. This method simultaneously groups both rows and columns of a data matrix. Think of it like organizing a spreadsheet by simultaneously grouping similar rows and columns. Pretty cool, right? I'll use a dataset where rows represent users and columns represent products. The data will be sparse, meaning most user-product interactions are 0, user didn't interact. Imagine a gigantic matrix with mostly empty spaces. I want to find 5 groups of users and 3 groups of products. I'm setting the number of clusters for rows, users, to 5 and the number of clusters for columns, products, to 3. This setting dictates how many groups the algorithm will find. I'm using the Sklearn library's Spectral algorithm. This algorithm is specifically designed for co-clustering. It's perfect for my task. The algorithm will output labels that indicate which cluster each user and each product belongs to. This variable contains the cluster assignments for each user row. This variable holds the cluster assignments for each product column. I have a multiple choice question to test your understanding of the co-clustering results. This statement checks if I correctly assigned each of my 5 user clusters a unique number. This statement checks if I correctly assigned each of my 3 product clusters a unique number. This statement verifies that the number of labels for users is equal to the number of users in the data. This statement verifies that the number of labels for products is equal to the number of products in the data. I'm analyzing data using a technique called spectral co-clustering. It's a way to find groups of similar things in a dataset, simultaneously grouping both the rows and columns. Think of it like sorting both students and their favorite subjects into related clusters. My input is a SPARSEMATRIX, which means it has mostly empty cells. This matrix shows how users interact with different products. Rows represent users, and columns represent products. A value in the matrix might show how many times a user bought a particular product. Because it's sparse, there's a lot of missing data, meaning many users haven't interacted with many products. I use the SPECTRALCOCLUSTERING algorithm from Sklearn. I tell the algorithm to find 5 clusters of users and 3 clusters of products. The 5, 3 specifies that it should find 5 row clusters, for users, and 3 column clusters, for products. After the algorithm runs, I get 2 outputs. Row underscore labels underscore backquote and backquote column underscore labels underscore backquote. Row underscore labels underscore backquote tells me which cluster each user belongs to. And column underscore labels underscore backquote tells me which cluster each product belongs to. This statement says that the row underscore labels underscore backquote output will have only 5 unique numbers representing the 5 user clusters that the algorithm found. For example, the labels might be 0, 1, 2, 3, and 4. Each user will have one of these labels. Similarly, this statement says that the column underscore labels underscore backquote output will only contain 3 unique numbers to represent the 3 product clusters. The algorithm will assign one of these 3 labels, maybe 0, 1, and 2, to each product. This statement means the number of elements in the row underscore labels underscore backquote array will exactly match the number of rows in the original user product matrix. Each user gets a cluster label. This is similar to the last statement. The number of elements in the column underscore labels underscore backquote array will exactly equal the number of columns in the original user product matrix. Each product gets a cluster label.